here we got a Spider-Man dynamic situation, and we've got Spider-Man and Venom both on the same web. And let's see, Spider-Man is, well, we'll say he's about 110 kilograms. Venom's a lot bigger. We'll say Venom is 350 kilograms. Now Venom is just hanging the web. Let's say Venom is at rest, so he's not doing anything. But let's say Spider-Man is actually sliding down the web, accelerating at 6 meters per second squared, maybe to try and kick Venom off his web. And what we're going to do, let's see if we can find the tension in the web here, and what is the tension in the web here. We don't have to worry about the tension at the bottom below Venom because it would just be zero because there's nothing hanging off of there. Now there's a couple different forces we can look at here, but the force of gravity is a really simple one. Let's look at the force of gravities of Spider-Man and Venom because we know they're going to be involved. So if I start with Spider-Man, I can find his mg. And his force of gravity is about 1,080 newtons. I'm going to do the exact same thing for Venom. If I do the exact same thing for Venom, I can just do mg. I can take the 350 and times that by 9.81, and I've got an mg of about 3,430 newtons. Okay, so let's see if that helps us out a little bit. I'm going to start with the bottom tension down there. Now, if we would cut the web right here, the tension would be zero on the remaining web, which tells me that Venom is responsible for all the tension here. Spider-Man has nothing to do with the tension below him. So Venom is supplying all of the tension on that bottom rope. Now Venom is just hanging on the rope. He's not moving up, he's not going down, he's not increasing or decreasing the tension, he's just hanging on it. So his force of gravity is actually supplying the tension in the web. So for that bottom part, the tension would just be the 3,430 newtons of force supplied by his force of gravity, and that's it. Now for the one up here, it's a little bit more complicated because Spider-Man isn't at rest, he's actually accelerating. So let's see what we can do with that. Let's see if we can find out, if we do F equals ma, we can find out how much force is actually being used to actually slide him down the web. So I do F equals ma for Spider-Man. We've got a mass of 110, we've got acceleration of 6, so that would give us a net force of 660 newtons. So there is 1,080 newtons of force pulling down on Spider-Man. 660 of that is being used to actually move him. So then, where's the other force? You're missing like 400 newtons of force. Well, that missing 400 newtons of force must be tension in the web supplied by Spider-Man. So there's 420 newtons for tension. Okay, so let's piece this together. Gravity is pulling Spider-Man down with 1,080 newtons. He's only using 660 of that to slide, so he's still sort of holding on with 420 sort of slow him down, which supplies tension in the web. So if it was just Spider-Man by himself, the tension in the web up here would be 440, but it's not just Spider-Man. The web at the very top has to support both Venom and Spider-Man. So So, first of all, that tension in the web is supporting Venom. So that tension up there has to have 3,430 newtons of tension just to support Venom. But then it also has another 420 newtons of tension because of Spider-Man. Now it's not just full weight because he's still sliding down, but 420 newtons of tension just to support what remaining force Spider-Man is actually applying to the rope. So if we put those two together, we have a total tension of 3,850 newtons of tension at the top. So there's 3,850 newtons of tension at the top. 3,430 of that is just to support Venom's weight, and then another 420 newtons of tension because Spider-Man is holding on a little bit, and then the rest of his weight force is then lost for his acceleration, which was the 660. Now this is just one way to actually look at the situation. There's a few other ways you could solve it, using accelerations and forces in different combinations, but the overall result should still be the same. And it makes sense that the tension in the top web is the greatest, and the tension in the middle is less because it has nothing to do with Spider-Man. And the tension at the top doesn't include the full weight of Spider-Man because he's sliding down the web, which is going to reduce the tension. If Spider-Man was climbing up the web, or Venom was climbing up the web and accelerating, then we would increase tensions by their F equals ma, but they're not. And if they're both at rest, they just be static equilibrium, the tensions would just be their weights acting on it. This middle one would be the weight of Venom, and this top one would be the combined weight of the two people together.